Hello everyone, I am Alok Kumar and I welcome you to the first lecture on properties of triangle. It's one of the most important chapters in both JEE Mains and Advanced, so you do well to have a good grip on it. So now let me share my screen with you all and start the lecture. Okay, so first let me quickly revise different formulae that are found in this chapter. Some are quite easy in the sense that every student remembers it, and some are somewhat forgotten, means one cannot bring them to mind when need arises. So it's better that you get to know all of them. And so let me begin with the simple ones. So first is your sine rule. That simply tells that A over sine of A equals B over sine of B and C over sine of C in triangle A, B, and C, my usual triangle. Nothing great about it. So ABC. And this ratio equals to R, where R is the circumradius. That is known as sine rule. It has got lots of applications. Then you have got something called cosine rule. It relates the sides of triangle with one angle. Means suppose BC is A, AB is C, and AC is B, and this angle is of course A. Then given BC and angle between them A, I can write A square as B square plus C square minus twice BC times cos of A. I can write three more relations, so I'll just write one and skip the other. So if I write B look at from this side B square, so this angle will come into play. B square is C square plus A square minus 2 times C times A times cos of B. And similarly, you can write the third one for C square. Still another is Napier's analogy. Napier's analogy, same Napier that gave us logarithm. So now Napier's analogy, that is one of the most important one, but students often forget that. So let me write it out. That's tan of A minus B over 2 equals A minus B over A plus B and times cot of C over 2. Notice this negative and this negative. That may help you in remembering that if A equal to B, then obviously capital A is capital B, angles are equal, and so both sides will give you 0. That may help you to fix in mind that this kind of thing is there. Now, the other one is again somewhat less known, less used. So that is, I'll call that is MN rule. So that goes by the name MN rule. It involves some cotangents. So I'll draw a triangle ABC, the usual triangle, and there is a point D on BC. So AD is a Chavian, and that AD makes an angle theta with the line BC, and you have got this name as alpha, this as beta, and as usual, this is your angle C, this is your angle B. Just writing it explicitly because they will find a place. So you have got two important versions of it. One is M plus N, cotangent of theta, that equals, and M and N, by the way, are the ratios. So BD over DC, that equals M over N. So they are not the lengths, they're the ratios. So M plus N times cot of theta, that equals M cot alpha minus N cot beta. If you want to involve the vertex angle, the angle made the vertex, that like BAD and DAC. And second one is if you want to involve the angles B and C at the base, so M plus N cot theta, but this time you have got N cot B. So this is like N times cot B minus M times cot of C. So let me quickly draw it here to remind you that if it is theta and you want to involve this B and this C, and this is M and N, so it's like N cot B and M cot C. That's just opposite. In this case, it was to help you memorize it. This is alpha and beta. So this is M and N, M cot alpha and N cot beta. Here N leads and M is following it. So N cot B minus M cot C, that goes by the name of MN rule. Next, we have got a result called Apollonius theorem. Apollonius theorem, which we used to find the median, length of median in a triangle. So the theorem says that if it is ABC is a triangle, and then AD is the median. So let's call the median at MA. Notation is MA, median to the side opposite A, that is like BC, median meeting this one at A. So MA. And so the result says that AB squared plus AC squared is twice AD squared and plus BD squared. Remember, BD and DC are equal and each is A over 2. If you plug it in here, we'll get C squared plus B squared is twice. This AD is, of course, we have named MA. So M sub A squared and plus BD squared is A squared over 4. And I simplify, bring MA squared on the one side. And so I can write this as 1 over 4 and 1 over 4 of 2 times. So let me just make it more clear. So 2 times B squared plus C squared minus A squared. That's what the good result for median. That involves given sides A, B, and C, you can find median. They are all sometimes called metric relation, that is giving lengths. So given the lengths of sides, I can find median in terms of lengths of sides. There is a hugely useful formula that generalizes it. So generalization is by Stewart's theorem. So that is Stewart's theorem. And Stewart's theorem says like this, that if you have got a triangle A, B, and C, and you have got a point D here, this time AD need not be a median. So BD and DC just anything. So let's call M and N. And so now M is BD and N is DC. They are now lengths, not ratios, unlike your cotangent thing. So they are lengths, M and N. So they will be dimensions of length. And now if AB, I will write C and AC as B, usual notations. So I can write that AD I will write as D. So the theorem says MB squared and plus NC squared, the opposites, MB squared and NC squared, just like AB squared. And that equals A times D squared plus MN. So that's A times D squared plus MN. And then you can calculate D in terms of A, B, C, and M and N. Here AD is a Chavian. So AD is a Chavian. It is spelled Cevein, but it is pronounced Chavian or Chavian, or maybe sometimes Cevian, but preferred is Chavian. So this MB squared plus NC squared is A times D squared. So I can find D in terms of A, B, C, and MN. That gives you this result. If you find it hard to remember, then there is a mnemonic. You can write this as BMB plus CNC is AD squared. I write DAD and plus MAN, or I may write as again as not like this, but then I can write as this MAN and plus DAD. And it is sometimes told at bomb plus sink is man plus dad. That's a fine acronym or mnemonic to just remember it. So keep it in mind. If you are the one who keep forgetting it, then that's for you. Okay. Then we have some applications for in the problem solving. So let me start with a problem, a little challenging one of the JEE mains level. So this is ABC is a triangle given. ABC is a triangle. The triangle is given. And you are given a point D here. These base angles are known. One is 75 degree. The other C is known to be 60 degree. And BD is just D is a point on AC. In other words, BD is just a Chavian, not necessarily something else. And triangle BAD area. So this is notation for area. This means area of figure X. This means area of figure X in notation. So BAD is root 3 times, and BCD means the ratio of the left triangle to the right is root 1 is to root 3. Root 3 is to 1. And then you want to find, that's all the data, and you want to find angle ABD. So you want to find this angle ABD. So let's see how you work it out. So one of the first things to note is this one, that you have got the base angle is given, A and C, and we also have given the ratio of areas. Now you remember your class 10th or probably 9th geometry that if you have got two triangles, say this is BAC and this is D, and if you drop the perpendicular H, then the ratio of areas of BAD and BDC is the ratio of their bases, AD and DC. In fact, I can write BAD over BCD, that equals half times base is AD and times H, and half times base of this DC and times same H, because height is, they share the same height. It's one is just obtuse looking, one is acute. And so you are getting, this is AD over DC. So the ratio of area of triangle is in the ratio of their bases. So this gives you AD over DC. So it means we get AD over DC is root 3. That's the first thing we get. AD over DC is root 3. Now let me derive one more thing which will be useful to connect AD over DC in terms of these angles, these kind of things. So we want ABD angle. So my diagram now becomes that this is BA and C, and this angle I want, this is ABD angle you want, that is theta. So obviously this angle, of course, we can write this is 45 minus theta, because total was 45, this was 75, and this was 60. So that was 135, and it's a triangle. So for 180 degrees of 45 minus theta. Now, let me do one background work and come back to you. This is ABC, the triangle, and suppose D is a point here, and this angle is alpha, and this angle is beta. Then I can derive that BD over DC is nothing, but this is just like AB over AC. So I can write this as AB over AC and times sine of alpha upon sine of beta, or the other form for this will be sine of C upon sine of A and times sine alpha upon sine beta. Let's look at this derivation through simple cosine sine rule. So this is BD over in triangle ABD. So triangle ABD, you get BD over sine of alpha, and that number is nothing but AB upon, so this is AB upon, and let's call it something phi. So AB upon sine of phi. And similarly, when I take triangle ACD this time, so I'll get here sine of DC upon sine of beta is now AC upon sine of 180 minus phi, both are phi. So once I divide them or equate sine phi from both sides, the same thing. So BD over sine alpha and over DC over sine beta, I'm dividing one by the other, and that equals, now sine phi goes away, we are left with AB over AC. And so that proves us that BD over DC equals indeed AB over AC, and times sine alpha goes here and sine beta comes here. So that's what you get by this kind of thing, that BD over DC. I can change AB and AC to side. That's simple, because we know that in the triangle that C upon sine C is B upon sine B. And so I can write that this AB is C, so I can write C upon B is sine C upon sine B. So ultimately this is sine C upon sine B finally, and times sine alpha upon sine beta. I always have stressed in my lectures this approach that main work you should do here. This is all background work. So don't make your diagram ugly by drawing so many figures and so many derivations. So the heart of the problem was that how to connect AD and AD over DC to these numbers, possibly this theta, because that we want theta and 45 minus theta, there's alpha and beta, and also 75 and 60 means base angle BC given. So I did not focus on 75. I just called let it A and let it C, let it A and C, that is given, and then we want to find that what we will do. Now apply this here. So this means that AD over DC, look at it again, BD over DC. So BD over DC is here. BD over DC is Sine of C over sine of B means sine of C, it comes here, but sine of B, and times sine of alpha upon sine of beta. So AD over DC, this will come first. So sine C over sine of A, and this is in same order, sine theta over sine of 45 minus theta. The advantage of this kind of approach is that even if there is a new problem entirely you have never seen, you can still apply these, and you quickly get to the point of the problem that, okay, this is what the paper setter has in mind. So AD over DC is this much. And now it's time to plug all the values. We are almost there. So AD over DC is given to be root 3. So let's write root 3 here, because that we got by ratio of areas. Sine C over sine A, sine C, so C is given to be 60, I assume. Let's check once back. 6, yes, 6 sine C is 60. So sine C is 60. So this root 3 by 2. A is 75. Now sine 75 degree is these things you must be able to write quickly. Root 3 plus by 2 root 2. If you forget an exam, always you can fall back on 45 and 30, and then you can break. So this is root 3 plus 1 over 2 root 2 in times sine of theta. That I will just left theta in sine of 45 minus theta. Don't worry, 45 is in degrees. I'm not putting a degree here. And so this will simplify as root 3 equals, then this root 3 and is here, root 3 goes off. So root 3 I will write here maybe. And this is root 2 and upon root 3 plus 1 and sine theta upon sine of 45 minus theta. So it seems that we are getting one equation in theta, which you should be able to solve. So let's start. So root 3 plus 1. So I will write root 3 plus 1 and times sine of 45 minus theta is root 2 times sine theta. That gives root 3 plus 1 time sine 45. So 1 by root 2 sine 45 cos theta minus cos 45 sine theta. That this one in root 2 times sine theta. I can send that root 2 to this side. It will multiply easily. So root 3 plus 1 times cos of theta minus sine of theta is twice of sine of theta. Let's collect the coefficients. So root 3 plus 1 cos theta is here. And we have got 2 plus 1 plus root 3 sine of theta. That becomes 3 plus root of 3 sine theta. I can factor a root 3 and I'll be left with root 3 plus 1 times sine of theta. And this cancels out, it's not 0. And then we are getting tan of theta is 1 over root 3, giving you, because you are dealing with a triangle, so theta is nothing but 30-degree angle. So this is your answer to the question, that theta is 30. In degrees we are to find. So it was a basic question, but still challenging. And examiner was able to test two things. One, properties of triangle, and also how good you are at solving trig equations, because yesterday we did trig equations. So you might be feeling that, okay, we can do these kind of things. Next is a problem that tells you that there is a triangle ABC in which A is 6. So length BC is given, A is given 6, B is given. So two sides are given, A and B, that is 6 and 3, some round numbers, and cos of A minus B, that is 4 over 5, that's some rational number. And you want to find the area of triangle. So you want to find delta. So apparently it's the data points are few, that you want just the two sides are given and cos of A minus B. Now you look for that how on earth is cos A minus B relates to this A and B. Then Napier's analogy come to your mind, because they involve exactly these numbers, and we just saw it that we wrote tan of A minus B over 2. So this is coming up, A minus B, difference is coming up, base angle something, and that is A minus B over A plus B and cot of C over 2. So it turns out that we know A minus B and A plus B, these things we know, this one, and tan of A minus B by 2 I can indeed find, because cos of theta is 4 over 5 given, and I want to find tan of theta over 2. So I can relate this using the half angle formula or something. So I can write here that cos of theta I know is 1 minus tan squared theta over 2, and upon 1 plus tan squared theta over 2. And if you do the work, then or you can better write this in a different manner also, directly tan squared theta over 2, that will be nice. 1 minus cos theta over 1 plus cos theta, because I want to find tan of theta over 2 given cos theta, so this is a better option. Now if I write using this one, then I get tan squared of theta over 2 is 1 minus cos theta, that is cos of a minus b, that's 4 over 5, and 1 plus 4 over 5, that gives us quickly 1 over 9. And because a minus b by 2, this angle is of course positive, and then we can assume that positive, that's not a problem. And this is less than 90, so it means I will select the positive sign. So tan theta over 2 is 1 over 3, and so we get this answer is 1 over 3. So we got 1 over 3, and a is given to be 6, so 6 minus b 3, and a minus b capital of course was greater because small a exceeds small b, sides exceed, and this is 6 plus 3 and times cot of c over 2, that gives me 1 over 3 is this side is exactly 3 over 9 cot of c over 2, so that's again 1 over 3, and so cot c over 2 equal to 1. That means that c by 2 equals 45 degree, and so c is 90 degree. It means the triangle is right angle triangle. And so you have a situation like, okay, the triangle c is 90 degree, it's right angle triangle, and let's call them a and b, and we are given the side line that bc is a, that is given to be 6, I don't care which one, and this is going to be 3, and so half times 6 times 3, that's 9. And so your answer is that area of triangle ABC, that's delta we said, and that equals 9 in of course appropriate units, maybe square centimeter or something that they will have to give. Okay, our next example, it just uses some other result. So we have to find aq cos b minus c plus b cube cos of c minus a plus c cube cos of a minus b over abc, where a is given to be 13, b is 14, and c is 15. Means that there is a triangle which sides are 13, 14, and 15. I want to find for this triangle, I want to find this ratio, a cube cos b minus c plus b cube times cos of c minus a plus c cube times cos of a minus b. And that's a cyclic expression. And so we will deal one term at a time. So given these things, I'll focus on aq cos b minus c. So let's focus on this term, aq times cos b minus c. How can you simplify? So what we can do is we can keep 1a outside, so 2a outside, so a squared, and I can write a times cos of b minus c, and I know that my a equals 2r sine of a, so I can write 2r outside and a squared, and this is sine a cos of b minus c. To bring symmetry into play, so directly don't deal with sine a cos b minus c, better write sine of a as sine of, this is pi minus b plus c, and so sine of pi minus theta is sine of theta, and so that equals sine of a sine of b plus c. In exam you should be able to do it very fast. So 2r squared, so I will absorb this 2 here, so I don't write a 2 here now, and so r squared, and this is twice of sine b plus c and cos of b minus c. Now this is gives me r a squared and 2 sine b plus c cos b minus c, so that you get 2 sine a cos b is sine of a plus b plus sine of a minus b. So sine of a plus b, so sine of 2b, and then plus sine of a minus b, so sine of 2c. So I have used 2 sine x sine y, just take x and y to avoid the conflict of notation. So sine of x plus y and plus sine of x minus y. We have 2 sine x cos y rather, so sine x minus y. We have done this. Now we have got this kind of thing that RA squared sine B cos B. So what we'll do that I want to rewrite it. I'll write RA squared and I'll write 2 sine B cos B and plus 2 sine C cos C. Now A squared is still this side. I get 2r sine B. So 2r sine B and cos B and plus 2r sine C and times cos C. Now that equals A squared times 2r sine B. We started the thing with 2r sine A. So 2r sine B is still B. So it's A squared and B cos B plus C cos C. Let me reflect on thing. There is a result called projection formula, which you used in determinants and matrices also. So projection formula in one of the problems. So projection formula tells that if you have got triangle A, B, and C, its projection, so it may be acute obtuse, does not matter. In all the cases, this BC is A, then you get A is this AB is C and AC is B. So A is, you can write as C times cos of B plus B times cos of C. Of course, if it is inside this foot of perpendicular, it's quite plain, C cos B and B cos C. But you can prove that even otherwise this holds. So this always holds. This is called projection formula because it's sort of projection that you are projecting the A on this one. Now, similarly, you can write 3 more. So A is C cos B plus B cos C. So now you have got this one. So I'll use the sigma thing, sigma cyclic A cube cos of B minus C. That number is now A squared and this is B cos B plus C cos C we got for this. Had we done for other thing, so you'll get in some order, you'll get B squared and A squared you're getting B cos B and C cos C. If B squared, you will get C cos C and plus A cos A. You won't get the opposite, you get the same, and plus C squared. And this time you get A cos A plus B cos B. Now is the time for some observation. So we rearrange. That's beautiful. We just rearrange some of the terms and we notice that if I pick A squared B to go with B squared A, this B squared A, so it means if I pair off A squared B cos B plus B squared A cos A, and of course to mode such terms, each containing 2 terms like this. This is AB, I can factor out A and B. So AB factors out. And then I am left with A times cos of B plus B times cos of A. Notice they are now opposite, A cos B. So it's just like here that it's like if you have got C, then this C will be A cos B and plus B cos A. And so that just equals C. So that is ABC. And each term will give you ABC and ABC. And so this answer you will get for this expression is 3 times ABC. So what you have derived is that A cube cos of B minus C plus B cube cos of C minus A and C cube cos of A minus B, that equals 3 times ABC. And so if you divide this by ABC, you wanted sigma AQ cyclic cos of B minus C over ABC, and that gives you 3. So it so turns out that you did not have to use the result about the triangle sides given. If you suspect in exam that such is the case, integer type or something, then you may try to plug some values, some good ABC, and try to see for at least 2 triangles that the ratio happens to be constant. Then you may take a chance and you may put that, oh, it's to be constant. So this was given just to distract your attention and not to focus. If I had given that find for all triangle, one could have, of course, set the values. So, of course, a good paper setter will change the things and he would not like to give any hint. So, ABC 13, 14, 15 does not matter after all. Okay. So, ABC is 3. Next, we will do one problem which involves cyclic quadrilateral. So, if we have a cyclic quadrilateral given this kind of data that you have got ABCD. So let's write like this, that you have got ABCD as cyclic quadrilateral. So ABCD is cyclic. And you are given AB equals 2 and AD equals 5. That is, the adjacent sides are given 2 and 5. Never mind, they don't look like 2 and 5. Geometry is the art of reasoning correctly on an incorrect diagram. That's what the saying goes. Now, this is AB is 2 and AD is 5. So 2 and 5. And BC, of course. So one of the third side is given to be 3. And you want to find DC. So BC also is given to be 3. And you want to find CD. And one more piece of data, that you are given this angle at 60 degree. So angle BAD, the bad angle bad, is given to be 60 degree BAD. So that's quite good actually. So let's start now. That first of all, the moment we know this 2, 5 and the angle between them, I can quickly find BD. So first of all, I will just draw this diagram again, and I'll observe that BD is immediately known. That's the plan. This is 60 degree. This is 2 and 5. So my BD squared is 5 square plus 2 square minus 2 into 5 into 2. So BD squared is this one. AD squared plus AB squared minus twice AD times AB times cos of 60. So times cos of 60 degree. So that is 25 and plus 4 minus 2 times 5 times 2 upon 2. That is 29, and minus 2 cancels 10. So that is 19. It means BD square is 19. BD is not that good. It is irrational. But we don't need BD. We in fact need BD squared. So we applied cosine rule once in triangle ABD, or say triangle BAD. We apply this cosine rule and we got this using cosine rule. Now let's call it 3. Let's just call, this is already x, this is x. Now again apply cosine rule in triangle, this time triangle DCB. Apply again cosine rule. This time this angle is known because it is cyclic, and so sum of opposite angles, angle A plus angle C, is 180 degree for a cyclic quadrilateral. Sum of the opposite angles is supplementary. So this is cyclic, and so 180 degree is there. It means that this angle is 120 degree, and we can apply on triangle DCB. So we'll apply BD squared is DC squared plus CB squared minus 2 times DC times CB and times sine 120 degree. So that is 19 given. DC squared is x squared I've assumed, and plus CB is given the third side, that is 9. So x squared plus 9 and minus 2 times DC, that is x, into 3 into cos 120. It's cos 120. So that is minus 1 over 2. And so you are getting x squared plus 9, and this is plus. So you are getting plus 3x. And when you transpose 19 to this side, you are getting x squared plus 3x minus 10 equals 0. And they factored out as x squared plus 5 and 2. So 5x minus 2x minus 10 is 0. X plus 5 minus 2x plus 5 equals 0. I can factor x plus 5. So x plus 5 times x minus 2 is 0. As x is not negative 5, x this side, x must be 2. And so your answer becomes that the fourth side, the remaining side of the cyclic quadrilateral, is 2. So that was based on cyclic quadrilateral. Next comes a result. Let me change the color maybe. So this is like, okay, so this one will work. So next comes a result that is really important, and people find different applications of it. So ABC, and you have got ABC is a triangle, and then you are given BE is a median, and of course you've got CF also a median. And what is special is that these medians are intersecting at an angle 90 degree. So of course, let's G with the point, the usual centroid where the medians meet. So they are the medians. They are the medians. So I denote it by this one, that equal. So BE and CF are perpendicular. So medians BE and CF are perpendicular, and G is their point of intersection. And now you have to prove that B squared plus C squared is 5 times A squared. You could also be asked B squared plus C squared over A squared equals. That's a good integer type. That answer equals 5. Let's prove it by two methods. So first solution, this is an important result. So first solution is that this gives us an opportunity to use Apollonius formula, Apollonius theorem, for finding length of medians. So length of median, you know that suppose BE. So this is MB squared. This length of median, MB squared. MB squared is 1 over 4 n times 2 times a squared plus c squared minus b squared. To remember, just remember this diagram, that if his median is there from this side median, then 2 times sum of the squares of these two sides, 2 times, but 2 is not here. Otherwise, it will of course cancel. So 2, and this is negative of b squared, the opposite side. So this is mb squared, straight away from Apollonius theorem. So mb squared is this much. And similarly, I can change the role and find mc squared, that is 1 over 4, and this time 2 times, and you will get a squared plus b squared and minus c squared. So that is your median length governed by these equations, square of medians, mb squared, mc squared. Now triangle BGC is a right angle triangle. So triangle BGC is right angle triangle. I can use Pythagorean theorem, and this is BG squared plus BG squared plus CG squared is BC squared. Now you know that in median, we know that BZ is 2/3 of BE. That is 2/3 of BE means the length of median, so 2/3 of MB. And so I can write this as 4 over 9 times MB squared plus 4 over 9 times MC squared is A squared. We already know MB squared, so I can plug in here 4 by 9 times 1 over 4, and this is twice B squared plus twice C squared minus A squared, and plus 4 by 9 times 1 over 4, that is twice A squared plus twice B squared minus C squared equal to A squared. 1 by 4, this 4 goes away. 9 I can transfer here, and so I'm left with 2b squared plus 2c squared minus a squared plus 2a squared plus 2b squared minus c squared is 9a squared. Now if I combine them, I will get 2n plus 2 4, so that is 4 times b squared plus c squared. So we will have 4 times b, we will have 4a squared other. So this is 2b squared plus c squared. In, let me just check, this is a quick check, is in order. So you will get here mb squared is this much. So we'll get, of course, here twice a squared. So this should be actually a squared, and this should be b squared. So you'll get 2a squared. So you should get here 2a squared and plus 2c squared minus b squared. And so you will get here 4a squared and plus b squared and plus c squared. That equals 9a squared. Now we got the coefficients correct. We got b squared plus c squared equal to 5a squared. And so we have related this a, b, and c for such a triangle in which medians are perpendicular. Let me do it again geometrically. That's very small solution, and it's much more elegant. So geometrically, we'll do like this. We'll use this result that if you have got a triangle PQR where P is right angle triangle, and so P is right angle triangle, and this is just median, so PQR, and call it S. So it is the midpoint. Then we know that PS equals SQ equal to SR. In fact, then this becomes, then these three all become the radius of a circle that passes through PQ and R with QR as diameter. So in a triangle P, you join vertex 90 degree to S, then PS equals SQ equals SR. That's trivial, but the result application is not trivial. So now we apply the same thing here. We are given A, B, and C, and we have got BE and CF, and they meet at G, and this is 90 degree. So for my purpose, only this is enough. My triangle is G, B, and C, this triangle, where this angle is something good, that's 90 degree. I know BZ, that's 2/3 of MB. I know this one, 2/3 of MC in terms of those numbers. And here, if I join the midpoint here, midpoint, then I know that these all are like equal. And see, this length is nothing but 1/3 of median A, because see AG, and going like here. So that is 1/3, 2:1. So 1/3. So I know that 1/3 of MA, MB, MC are not needed in this approach. 1/3 of MA equal to BD. So 1/3 of MA equal to BD is A over 2. And so I can square it, and I can write 1 over 9 MA squared is A square over 4. And so 1 by 9 times MA squared. MA squared is 1 over 4. And 2 times B squared plus C squared minus A squared is A squared over 4. That 4 cancels. You are left with 2 times B squared plus C squared minus A squared is 9A squared. Bring that A squared to the other side. 2 times this is 10A squared. And so BS plus C squared equal to 5A squared. And thus we are done. This is much more satisfying method. And so by this method also we got that B squared plus C squared is 5 times A squared. My next problem involves the application of different types of formula for area of triangle. So you have given a triangle A, B, and C, the usual triangle, in which base BC is given to be 6. So A is given to be 6. Unit will be given to you. And you are also given that area delta is 12. So delta is 12, must be in square centimeter if this is in centimeter. And then BC is 6. And so you want that this angle A, you are saying that A is given by, angle A is given by, there is a relation involving angle A. So angle A is given by 8 sine A minus 6 cos A equal to 3. This one, one more thing is given, that's B minus C, the difference of base angle, angle B minus angle C, or difference, that is given to be 60 degree. So let me read the question again. That given triangle ABC in which the area is 12, side A is 6, and difference of base angles is 60 degree. Prove that angle A, the angle opposite to the given base, this BC, is given by 8 sine A minus 6 cos A equal to 2. Means you don't have to find the value, but you just have to find that what A satisfies. This problem is known to cause difficulty to students. The idea is that for delta, you have got some expressions like delta is area is half BC sine A, that you are much familiar with. Then half times base into height, that is coming to you from class 8th onwards maybe. So half times base times height. And then we write delta is ABC over 4R. So those are different deltas, and Heron's formula also. So delta is square root of S, S minus A, S minus B, S minus C. But sometimes in exam, you may have derived delta from these things, or starting from scratch, delta in terms of variables which you want. See, here you have got A, B, C, and then, so not BC exactly, but then B and C. So B minus C is given, other is unknown. So can I write area in terms of where difference of angle will come? Or A, B, C, these angles will be involved. So let's attempt this. So delta I will write as delta is half BC sine C. So already sine A you want. So I'll use that half BC sine A. That is one I will use. Now, I want these things to write in terms of something else, such that it involves, so delta I want in terms of A, and then angle A, B, and C probably. So in terms of A and A, B, C, this kind of thing. So let me do this work here, that you have got, or only B and C base angle. So A, B, C is there, B, C, and this is your, this kind of thing. So let's start like this, that this area is half BC sine A. Now you want to keep A and B. So C has no role. So C I will write as C by sine C is B by sine B. And so we can write like this, that rather we want A also. So, okay, so if you want A, so we'll write half. So let me write it here. Half into, I write B, I leave. So half BC, or half BC sine A again I rewrite as half, and A you want, but you don't want this one. So half AB. So I can write half AB sine C. In that, what will happen? That already A is there, so we don't worry about A. A you want. So it is same thing. Instead of this, we are using half AB sine C. Now half times. So I change my approach. Half times A you keep, and B. So you know that B by C is sine B over sine C, thanks to sine rule. And so I can write this B as C sine B over sine C, and I can put it here again. But then I want in the form of A. So better would be that I write B by A is sine B over sine A. So in that I can write B equal to A times sine B over sine of A. So half times A, and B is A sine B over sine of A, and this is sine of C. So I'm getting half, and then A square sine B sine C over sine of A. It means that if I want to write in terms of angles A, B, and C, I have got this result, half A squared sine B sine C by cos A. So let me write this result here. So this delta is now half because BC are involved. So I'll write half A square sine B sine C over sine A. This becomes a new result for you, new formula. But I don't want B and C, difference is given. So I write 1 by 4 A square and twice sine B sine C over sine of A. And that gives me 1 by 4 A squared 2 sine B sine C. That is cos of B minus C, and plus cos of B plus C. So I can write like this, cos of B minus C, and it should be rather cos of B minus C and negative. So this is negative here. So we'll change that, and we will write that this is like this. So cos B cos C plus sine A sine B sine C, and this is negative. So negative will come here, and upon sine of A. So 1 by 4 A squared cos B minus C is given to be 1 over 2 because B minus C is 60 degree. So that is okay. And minus cos B plus C I can write as cos of pi minus B plus C, plus will come. So cos of A. So this is cos of A, and upon sine of A. So now this form I am using, this delta, you see this delta. Now this delta is given. So let me check what delta is. So delta is given to be 12. And so I can write that this is 12 is, so 12 is 1 by 4 and times A squared. And A squared is given to be 6. So that is 36 and half plus cos A and upon sine of A. So that is 4 and 9, 36, and 3, 4 and 3, that is this one. So I am getting 4 sine A is 3 times 1 plus 2 cos A and over divided by 2. That is 2, 4, 8 sine A is 3 plus 6 cos A. And we are done because we got 8 sine A minus 6 cos A equal to 3. So we got that, okay, such an A satisfying this one must satisfy some equation. And so this was to be found out that 8 sine A minus 6 cos A equal to 3. So this is what we got. So notice how we derive this formula. So I'll write it separately, that we derived a good result, that if you have got this A, B, and C, this kind of thing. In fact, we did A and B, and then you want delta in terms of something. So what you have derived is this, that half A square sine B sine C by sine A. So it's saying half A square sine B sine C by sine A. This is also expression of area in terms of this angle involving A and BCA, and of course other will come. So A and B minus C it involves. Next is a problem that makes use of again some result which is not often remembered. So the question says that you have got a triangle ABC, and you have got point P and Q here, such that this BD equals BP equals PQ equals QC. So they are all equal. So just join P and Q. and call them angles alpha, beta, and gamma. And you were given that the tangent of these angle, so the tangent of these angle tan alpha is T1, tan beta is T2, and tan gamma is T3. So these things are given. And now I want that, rather I want to prove, or I want to find the value. So I need to find the value of 1 by T1 plus 1 by T2 times 1 by T2 plus 1 by T3 and over 1 plus 1 over T2 squared. So the moment you see these problems, probably it may be integer type or something. The moment you see this problem, the trick is not to get afraid, rather think of that what could be involved. So it's not your sine, not your cosine, because those you are able to catch well. So they are not sine cosine, but because ratios, because they are in some ratios like 1 1 1 and tan is involved, so you will remember mn rule. So let's apply mn rule to it. You will see you will have to apply it more than once. So mn rule I will first apply in triangle ABC. So in triangle ABC, so let me try triangle ABC, and I have got a point. I can choose anything. I chose Q. So this is Q. This is 2:1 ratio. This was your alpha, and this is your beta plus gamma. So this, or this is alpha plus beta, and this is gamma because you have chosen Q. So this is this. Let's look at this one: AQ, alpha, beta, and gamma. So now we are ready to apply. Let's call this angle theta. So m plus n cot theta. Using the result m plus n cot theta is m cot alpha minus m cot beta, but not these alpha beta. This alpha and beta is not this, but rather it is ABC and this alpha and beta. So here 2 plus 1 cot theta is 2 times cot of alpha plus beta minus cot of gamma. So this will be 3 times cot theta is 2 times cot of alpha plus beta minus cot of gamma. That's 1. Let me search one more triangle, and that is here that I can apply in this triangle. So I can take again A, P, and C. So triangle A, P, and C, and you have Q. Now this angle is nothing but beta, and this is gamma, and this is 1:1 because now you have got this one again, and this is still theta. So I get twice cot theta is cot of beta and minus cot of gamma. You can get like this 2 cot theta. That is number 2. Now I can eliminate theta from this because I don't need. So I can simply divide. So if I divide, I get 3/2 is 2 times cot of alpha plus beta minus cot of gamma upon cot of beta minus cot of gamma. Now just use all the things. So I will cross multiply. So this is 3 times cot of beta minus 3 times cot of gamma is 4 times cot of alpha plus beta minus twice of cot gamma. Now lot of things are there. So first I will write this one, that 3 cot beta minus this one. So what we can do, we can of course write 3 cot beta and minus cot gamma. So that is 2 cot gamma. 1 gamma is here, so I can write 3 cot beta minus cot gamma. I gamma transferred here, and that I can write as 4 of cot times alpha plus beta. So I can write 4 of cot times alpha plus beta, and then 4 times this number I can write as, by result, cot alpha cot of beta minus 1 upon cot of alpha plus cot of beta. Now 3 cot beta minus cot of gamma. So let me write now as cot. I will write cot alpha as cot. I've written tan alpha is this one. So let me write cot alpha as say m2. So 1 by T. So cot alpha is M1, cot of beta is M2, and cot of gamma is M3. Just for abbreviation, this is T3. So this is 3 times M2 minus M3 is 4 times now M1 M2 minus 1 and upon M1 plus M2. So I can write M1 plus M2. Now let's multiply, cross multiply 3M2 minus M3 and times M2 plus M1. Now equals, this is 4 times M1 M2 minus 1. Now 3M2 squared, 3M2 squared, and plus 3M2 M1 minus M2 M3 and minus M3 M1, that equals 4 times M1 M2 minus 4. Now is the time to rearrange. So I can write 3M2 squared and plus 4. I bring this plus 4 this side. And so I can write 4M1 M2 minus 3M1 M2 plus M2 M3 plus M3 M1. So that gives 3M2 squared plus 4 equals M1 M2 plus M2 M3 M2 M3, and then I can write M3 M1. Now notice that if I write here some other numbers, like say this is nothing but M2 times M1 plus M3 and plus M1 M3. So if I add one more M2 squared, think of this way, that M2 squared plus M2 times M1 plus M3 plus M1 M3, that is nothing but M2 plus M1 and times M2 plus M3. So this kind of thing can be okay. So if I add, so I'll write 3M2 squared plus 4 plus M2 squared. This is added, M2 squared plus M2, M1 plus M3 plus M1 M3. Now this gives you 4M2 squared plus 4 is M2 squared plus M2, M1 plus M3 plus M1 M3. I can combine them and say I can take factor M2 squared plus M2 M1 plus M2 M3 plus M1 M3. So M2 times M2 plus M1 and plus M3 times, this is M3 times M2 plus M1. So we'll get M2 plus M1 and times M2 plus M3. So ultimately we get this, that 4M2 squared plus 1 equals M2 plus 1 and times M2 plus M3. Now notice that our M2 was cot of beta, M1 was cot of alpha, and M3 was cot of gamma. And so we can write here that we are given T1 is tan of alpha. So we know that M1 is 1 over T1, M2 is 1 over T2, and M3 is 1 over T3. So you make such generate here. You got 4 1 by T2 square plus 1 is 1 by T2 plus 1 by T3 T1 and times 1 by T2. So we can again write 1 by T2 and plus 1 by T3. And so ultimately we can write this as, just bring this side, and we can write 1 by T2, 1 by T1 times 1 by T2 plus 1 by T3 whole over 1 by T2 square plus 1, and that number equals 4. And so my answer here is 4. So in all of these problems today, you have seen that how we have used different results to come up with something really useful, and I hope that you will have to remember them to make use of them in the exam when they appear. Okay, so that's time to go now. So let me stop sharing. Okay, so that's all for today.